Imagine a world hotter than the surface of a star. A place where the sky burns at over 7,000 degrees Fahrenheit, tearing molecules apart and vaporizing solid metal into thin air. You aren't looking at a sun. You are looking at KELT 9b, a planet that defies the laws of physics. It is a gas giant locked in a death spiral, its atmosphere boiling off into the freezing void like the tail of a bleeding comet. But out there, in the quiet, endless dark between the stars, extreme heat is only one way the universe breaks its own rules. Somewhere in that abyss drifts a phantom world, darker than coal, a planet that silently absorbs almost all light, hiding an unimaginable secret beneath its pitch-black skies. We will find it soon, but for now, get comfortable. Let your body rest, let your thoughts wander, and let's drift into the shadows where the impossible becomes real. There are worlds out there that challenge everything we thought we knew about what a planet can be. They blur the fragile boundary between a planet and a star. These are the ultra-hot Jupiters, blazing, storm-racked infernos orbiting so close to their host stars that a single year lasts only a few hours. They are beautiful, violent, and fleeting. Slowly, relentlessly, they are being torn apart by the gravity of their suns, destined to dissolve into the dark. But heat and gravity do not always destroy. Sometimes they forge things that sound like myths. Imagine a world made almost entirely of diamond. It feels like a concept pulled straight from science fiction. Yet, under the right conditions, it is entirely real. If a planet forms around a star with more carbon than oxygen, the fundamental ingredients of its birth change drastically. Consider 55 Cancri, a super-Earth twice the size of our own planet. Deep within its interior, unimaginable pressure and staggering temperatures compress enormous amounts of carbon. This pressure creates vast, global regions of crystalline diamond. But do not picture a glittering, sparkling world. There is no jewelry here, only suffocating darkness, searing heat, and a density so extreme it defies human comprehension. A planet forged from carbon, where the mountains themselves might be made of buried crystal, locked forever beneath the surface. And yet, even these crystalline realms are often bound by a cruel cosmic law. Not all planets spin freely like the Earth. Some are tidally locked. Imagine an entire world where one hemisphere is forced to stare into the face of its star forever, scorched by an unending, merciless daylight. The other hemisphere faces outward, trapped in a frozen, eternal night. An abyss of ice and shadow where no dawn will ever come. But right between them lies the Terminator line, a twilight zone, a ring around the planet, where the light is always low, the shadows stretch forever, and the temperature might be just right. There is no sunrise here, and no sunset, just a soft, slanted glow of a sun locked forever on the horizon. Could something live in that narrow band of shadows? Could life find a way to thrive on the razor's edge between fire and ice? We will explore the strange biology that might hide in these shadows later. But first, we must look up, because on some worlds, the sky itself is falling. From a distance, it looks like home, a soft, deep blue marble, suspended against the black canvas of space. If you were approaching the exoplanet HD 189733b in a starship, you might feel a brief surge of comfort. That azure shimmer looks exactly like the gentle oceans of Earth. It invites you in. It promises tranquility. But that color is a lie. There is no water here. The soothing blue is a trick of the light, scattered by an atmosphere of unimaginable violence. As you descend through the cloud layers, the illusion shatters. The temperature outside spikes to a blistering 1,700 degrees Fahrenheit. But the heat is not the most terrifying part. It is the wind. The atmosphere of this world is caught in a perpetual, screaming hurricane. Winds whip around the planet at over 5,000 miles per hour, roughly 7 times the speed of sound. And carried within those deafening winds is the true source of the planet's blue tint: silicate particles, the very building blocks of glass. In the upper atmosphere, these extreme conditions cause the silicates to condense. They form clouds, and they fall as rain. But in a 5,000 mile per hour gale, the rain does not fall down. It sweeps sideways. Torrents of molten glass flying faster than a bullet, slicing through the darkness in a horizontal storm of jagged glowing shards. It is an inferno of flying glass, a beautiful, violent, utterly uninhabitable cauldron. It reminds us that nature's imagination is far more brutal than our own. Yet, not all alien weather is purely destructive. Sometimes, the extreme physics of distant worlds create skies of haunting, mesmerizing beauty. When we think of clouds, we picture water vapor, soft, pale, and shifting. But on certain massive exoplanets, gas giants roasting under the glare of their nearby suns, the temperatures soar so high that rock and metal vaporize into the air. Imagine a sky where the clouds are not made of water, but of vaporized minerals. On planets like HAT P7b, the immense heat causes compounds like aluminum oxide to rise, cool, and condense high in the atmosphere. Aluminum oxide, in its crystalline form on Earth, is known as corundum, and corundum is the mineral that forms rubies and sapphires. Picture it. You are drifting high above the storm deck of a massive gas giant. The winds are heavy and hot, and above you, the clouds do not just block the light, they capture it. They shimmer, a sprawling planetary storm system made of liquid gems. As the star's light filters through these clouds, the sky might bleed into hues of deep, brilliant red, or scatter into a blinding oceanic violet. Snowfall on a world like this wouldn't be soft white flakes. It would be a slow-motion descent of crystalline dust. Tiny shards of sapphire and ruby drifting down into the crushing depths of the planet, melting back into vapor before they ever reach a solid core. A world wrapped in a storm of precious stones, glittering in the absolute silence of space. But the strangest skies are not always defined by what is in the clouds. Sometimes, the greatest wonder is what lies beyond them. Since the early days of science fiction, humanity has dreamed of looking out over an alien horizon and seeing 2 suns setting at the same time. The twin sunsets of Tatooine were once thought to be nothing more than a cinematic fantasy, a beautiful myth. But the universe is vastly more complex than our early models suggested. These binary star systems, where 2 stars orbit a common center of gravity, are remarkably abundant, and we now know that planets can and do form around them. We call them circumbinary planets. Imagine standing on the solid, rocky surface of one of these worlds. The sky above you is a complex, ever-shifting clockwork of light. You wouldn't just have one sunrise. Depending on the day, you might see a massive, searing blue star rise in the east, painting the landscape in harsh, pale light. Hours later, a smaller, deep red dwarf star might crest the horizon, casting a second set of shadows behind everything you see. Your shadow splits in 2, one sharp and black, the other soft and crimson. The seasons here would not be simple cycles of summer and winter. They would be chaotic, driven by the cosmic dance of the twin suns as they pull closer together and drift further apart. On some days, the stars might align, merging their light into a single blinding point. On others, they might sit on opposite ends of the sky, leaving the planet bathed in a bizarre, shadowless twilight, where night never truly falls. These delicate, complex systems prove that gravity is a master architect, capable of balancing worlds on a knife's edge. But what happens when that balance breaks? What happens to a planet when it is ripped from its sun entirely, banished to the darkest, coldest voids of the universe, where no light will ever reach it? We are about to enter the graveyard of the galaxy. When we look up at the night sky, we look for light. We expect planets to be bright beacons, reflecting the brilliant rays of their host stars like mirrors suspended in the void. Venus, Jupiter, Mars, they all shine because they reflect. But there is a world that refuses to shine, a world that swallows light whole. 750 light-years away from Earth lies Tri-Es 2b. It is a gas giant, roughly the size of Jupiter, but that is where the similarities end. Tri-Es 2b is the darkest planet we have ever discovered. It reflects less than 1% of the starlight that hits it. To put that into perspective, it is darker than black acrylic paint, darker than soot, darker than the blackest piece of charcoal you have ever seen. Why is it so dark? Astronomers still don't entirely know. It may be due to a lack of reflective clouds, or an atmosphere flooded with light-absorbing chemicals like vaporized sodium, potassium, or titanium oxide. It is a planetary black hole, silently devouring the light of its sun. But Tri-Es 2b is not completely pitch black. Because it orbits so incredibly close to its star, its atmosphere is superheated to over 1,800 degrees Fahrenheit. At this extreme temperature, the planet emits a faint, eerie glow. If you could fly a spacecraft near it, you wouldn't see a bright sphere. You would see a massive, looming shadow against the stars, glowing with a deep, dull red light, like a dying ember slowly suffocating in a campfire. A ghost planet, a glowing shadow. But as eerie as Tri-Es 2b is, it still has a sun. It is tethered to a star, anchored by the comforting pull of gravity. It has a home. What happens when a planet loses its home? The birth of a solar system is a violent, chaotic event. In the early days of planet formation, massive worlds play a dangerous game of gravitational billiards. In this cosmic violence, not every planet survives, and not every planet stays. Sometimes, a world is violently ejected, ripped away from the gravitational embrace of its sun, and violently thrown out into the infinite, freezing abyss of interstellar space. We call them rogue planets. They are the orphans of the cosmos. Imagine, for a moment, standing on the surface of one of these wandering giants. There is no sunrise. There is no sunset. There are no days, no months, no years. The sky is an eternal, unchanging dome of cold, distant stars. The temperature plunges to near absolute zero. You are drifting through the unimaginable emptiness between star systems, untethered, unseen, and utterly alone. Astronomers now believe that these rogue planets are not rare anomalies. In fact, there could be billions, perhaps even trillions, of these orphaned worlds wandering our Milky Way galaxy in the dark. There may be more planets drifting alone in the void than there are stars in the sky. Some are massive gas giants, slowly cooling in the endless night. Others are rocky worlds, much like Earth, but locked in a permanent deep freeze, their atmospheres long collapsed and frozen solid as snow upon the dead ground. It sounds like the ultimate dead zone, a barren wasteland where nothing could ever possibly happen. But the universe has a strange habit of hiding miracles in the darkest places. Even drifting in the absolute freezing vacuum of deep space, a rogue planet might not be completely dead. Deep inside, crushed by millions of tons of rock, a molten core could still be churning, generating geothermal heat from radioactive decay. If a rogue planet has a thick outer shell of ice, that internal heat could melt the bottom of the ice crust. This creates something breathtaking, a vast, global, liquid ocean, completely sealed off and protected from the freezing vacuum of space by a miles-thick shield of ice. Which brings us to a haunting question. Down there, in the crushing, pitch-black depths of a rogue planet's hidden ocean, warmed by volcanic vents and fueled by ancient chemical reactions, could something be swimming? Could alien life evolve, thrive, and die in a pitch-black sea, completely unaware of the universe above, having never once seen the light of a sun? Perhaps the most abundant life in the galaxy doesn't live in the light. Perhaps it hides in the dark. But to find endless water, we don't always have to look in the freezing shadows. Because there are worlds where water isn't just hidden beneath the surface, it is the surface. Worlds where the oceans have no bottom. We call Earth a water world. From space, our home is a brilliant, swirling marble of blue and white. But in cosmic terms, our oceans are nothing more than a thin, fragile film resting on a massive sphere of rock. Even at its deepest point, the Mariana Trench, Earth's ocean is only about 7 miles deep. Now, erase the land. Erase every continent, every island, every shallow reef, and every shoreline. Imagine a planet where the surface is entirely liquid, a true water world. On these exoplanets, there is no coast to break the waves. The winds sweep across a global ocean without interruption, building swells that could dwarf the tallest skyscrapers on Earth. If you were floating on the surface of one of these worlds, the water would stretch to the horizon in every direction, an endless, unbroken circle of deep, hypnotic blue. Above you, an alien sun quietly tracks across the sky. Below you is an abyss that challenges human comprehension. Let us descend. As we sink beneath the waves of this global ocean, the light from the alien sun quickly begins to fade. At 10 miles deep, we are already deeper than any ocean on Earth. But here, we have barely scratched the surface. We sink further, 50 miles, 100 miles straight down. The darkness is absolute. The weight of the water above is no longer just heavy. It is a crushing, godlike force. You might expect that at the bottom of this world-spanning ocean, we would finally hit a rocky seabed, a dark, muddy floor where tectonic plates slowly grind together. But physics has a surprise waiting in the dark. At depths of 1,000 miles or more, the pressure becomes so extreme that it alters the very molecular structure of water. The water molecules are squeezed together so tightly that they can no longer flow. They are forced to lock into a rigid, crystalline grid. The water freezes, but it does not freeze because it is cold. It freezes because it is crushed. Scientists call these exotic states of water Ice 7 and Ice X, Ice 10. This is not the fragile floating ice you put in a glass of water. This is high-pressure ice. It is heavier than liquid water, so it sinks. It is as dense, hard, and solid as bedrock. On these water worlds, the ocean floor is not made of stone. It is made of thousands of miles of warm, solid ice, a crystalline mantle wrapping around the planet's core. Imagine a mountain range made entirely of ice that never melts, groaning and shifting under the weight of a 1,000-mile deep sea. A place where water acts like geology. But not all water worlds are cold, quiet abysses. If we take one of these global oceans and push the planet closer to its star, the story changes completely. The intense heat from the star boils the surface of the ocean. But because the planet is massive, its gravity is too strong to let the vapor escape into space. The result is a steam world, a planet wrapped in a thick, swirling global fog. There is no visible surface. The atmosphere is made almost entirely of superheated water vapor. From space, it would look like a featureless glowing pearl, shrouded in an impenetrable mist. Beneath that thick steam, the temperature and pressure rise until the boundary between gas and liquid completely disappears. The sky smoothly transitions into a boiling ocean, with no horizon to separate the two. A world of eternal twilight and stifling heat. And yet, water is not the only thing that can build a world. In the freezing, lonely outskirts of distant star systems, temperatures plummet so low that gases we consider invisible on Earth, like ammonia, methane, and nitrogen, condense and freeze. They form exotic snows that drift down to coat the surface of planets in pale, ghostly shades of pink, yellow, and blue. These are massive, frozen worlds where chemistry writes the landscape. Glaciers of methane flowing slowly under a dim, distant sun. Valleys carved by liquid ammonia. These deep oceans and frozen wastelands seem like lonely, isolated places. Entire worlds lost in the dark. But what if I told you that the most magnificent oceans in the universe might not be on planets at all? Imagine looking up from the surface of a pitch-black sea and seeing a gas giant thousands of times larger than our moon, filling the entire sky. Welcome to the realm of the exomoons. Where there are planets, there are almost certainly moons. In our own quiet corner of the galaxy, the solar system is teeming with them. Jupiter and Saturn alone host dozens of satellites, ranging from tiny, heavily cratered captured asteroids to massive, dynamic worlds hiding deep, warm oceans beneath shells of cracked ice. But out there, in the uncharted depths of the Milky Way, everything is magnified. Everything is grander. Imagine a gas giant, not just the size of Jupiter, but 10, 15, or 20 times more massive. A super Jupiter, drifting silently through the habitable zone of a distant, stable star. The gas giant itself has no solid surface. It is a swirling cauldron of crushing pressure, raging storms, and toxic gases. It cannot support life as we know it. But it is not alone. Caught in the immense gravitational web of this behemoth are moons, exomoons. And because the parent planet is so massive, these moons are not small, lifeless rocks. They are colossal. Imagine an exomoon the exact size and mass of Earth. It has a rocky crust, deep liquid oceans, and a thick, breathable atmosphere. But its sky is nothing like ours. If you stood on the shore of an ocean on this world, the horizon would be dominated by a staggering, almost terrifying sight. A massive gas giant filling nearly half the sky. Its swirling bands of ochre, crimson, and deep blue would loom over you like a celestial ceiling, thousands of times larger than our moon appears from Earth. Imagine the color of that sky, the starlight filtering through the moon's own atmosphere, casting a sapphire blue hue, while the towering gas giant reflects a fiery amber. The rings of the parent planet, if it has them, would slice across the heavens like a glittering bridge of crushed ice and stardust, casting a sharp, dark shadow that cuts the world in half. Every few days, the moon would pass directly behind the giant, plunging the world into a sudden, deep eclipse. The temperature would drop. The sky would darken, lit only by the faint, eerie glow of the gas giant's auroras. Vast storms of glowing plasma dancing across the planet's magnetic poles, crackling in the absolute silence of space. But the most profound force on this moon is not the light, it is the gravity. You could press your ear to the ground and hear the deep, resonant groaning of the ice and rock, the sound of a world being slowly stretched. The immense pull of the gas giant does not just hold the moon in orbit, it needs it. As the moon travels along its elliptical path, the gravitational forces stretch and compress its rocky interior. This constant flexing generates immense internal friction. Heat. It is a slow, geological heartbeat. This is called tidal heating, and it changes the rules of habitability entirely. Even if this exomoon orbited far beyond the traditional Goldilocks zone, in a region where the light of the star is too faint to warm the surface, it wouldn't matter. The moon is heated from the inside out. Beneath its surface, volcanoes might erupt, not with molten rock, but with slushy water and ammonia. Cryovolcanoes, spewing massive geysers of ice high into the alien sky, falling back down like slow-motion snow. And beneath that icy crust lies an ocean, a warm, dark global ocean, kept liquid by the steady, rhythmic heartbeat of tidal friction. Down in those depths, hydrothermal vents might spew rich minerals and energy into the water, creating an oasis in the dark, a cradle. It forces us to ask a humbling question. What if the most common homes for life in the universe are not planets at all? What if Earth is the exception, and the true sanctuaries of the cosmos are these hidden moons, quietly orbiting giant, lethal worlds? Entire ecosystems could exist in the shadows of gas giants, entirely unaware of the massive, swirling planet that commands their tides. But as serene as this hidden sanctuary might seem, the universe is not always a place of gentle balance. Gravity is a sculptor, but it is also a destroyer. While some worlds dance in perfect, stable harmony, others are caught in a spiral of absolute chaos. There are planets that rebel against the very mechanics of the cosmos, worlds that orbit backward, worlds where an entire year flashes by in a matter of hours, and others where a single season lasts for lifetimes. We are about to leave the quiet oceans behind and step into the wildest, most unstable orbits ever discovered. We are intimately bound to the steady, predictable ticking of a cosmic clock. On Earth, we rely on the comforting rhythm of 24 hours in a day and 365 days in a year. It is a loop of time that governs everything we know. But out in the wild, untamed expanses of the Milky Way, time and gravity do not always obey our rules. In fact, on some worlds, the concept of time itself begins to warp and unravel. Imagine a world where an entire year, a full journey around its sun, flashes by in the span of a single afternoon. Consider the exoplanet Kepler, 78b. It is a rocky world, just slightly larger than Earth, but it orbits its star at a distance so terrifyingly close that it completes a full year every 8.5 hours. If you stood on its surface, the star would not just be in the sky, it would be the sky, an overwhelming wall of blinding nuclear fire dominating the horizon. Because of this extreme proximity, Kepler 78b is a world of absolute liquid rock. Its surface is an endless, churning ocean of magma, superheated to thousands of degrees. The gravity of the star pulls and stretches the planet's crust, slowly tearing it apart. It is a world living in fast forward, a fleeting spark skimming the very edge of destruction. Now, let time stretch out. Let the frantic spinning of the inner worlds fade away, and drift with me into the cold, quiet outer edges of a star system. If some planets race against the clock, others are caught in an agonizingly slow, silent drift. Far out in the dark, orbiting at the very limits of its star's gravitational reach, lies GU Piscium b. It is a massive gas giant, but its journey is nothing like Jupiter's. It is so distant from its sun that a single orbit, 1 year on this planet, takes roughly 1,000 Earth years to complete. Imagine the seasons on a world like this. Change is not measured in months, but in generations. A single freezing winter would last for centuries. The sunlight reaching this world is so incredibly faint that the star looks like nothing more than a slightly bright star in a pitch-black sky. It is a lonely, silent sentry, taking a millennium to trace a single, enormous circle in the dark. But extreme speed and extreme slowness are not the only ways a planet can rebel against the cosmos. Perhaps the most unsettling oddities are not about time at all. They are about direction. When a star is born, it forms from a swirling, collapsing disk of gas and dust. Because of the conservation of angular momentum, everything in that resulting solar system, the star, the planets, the asteroids, usually spins and orbits in the exact same direction. It is a synchronized cosmic carousel. But the universe is not a perfect machine. It is prone to chaos. Meet WASP-17b. It is a massive world that refuses to follow the flow. While its host star spins in one direction, WASP-17b orbits backward. It pushes against the current in a retrograde orbit. How does a planet end up moving backward? It speaks to a history of unimaginable violence. Millions of years ago, a catastrophic near collision, a gravitational shove from another massive body, or a chaotic dance with a passing star likely derailed this planet, flipping its trajectory entirely. It is a cosmic exile, moving in quiet defiance of the system that birthed it. And WASP-17b hides another bizarre secret. It is nearly twice the size of Jupiter, but it contains only half the mass. It is what astronomers call a puffy planet. Its density is lower than that of styrofoam. If you could find an ocean large enough somewhere in the universe, this massive, bloated giant would float on the water like a balloon. It is an elastic, swollen world, stretched by the heat of its star, vast in size but fragile in substance. These strange, stretched and backward worlds show us how flexible a solar system can be while the sun is still shining. But stars do not live forever. Eventually, the fuel runs out. What happens to a planet when its sun dies? What remains after the apocalypse when a star violently collapses or explodes with enough force to outshine a galaxy? Prepare yourself. We are about to cross the threshold and enter the graveyards of the cosmos. Stars are not immortal. They are colossal engines, and eventually, like all engines, they run out of fuel. When a star like our Sun reaches the end of its life, it swells into a monstrous red giant, swallowing its inner planets in a slow, agonizing wave of fire, before eventually collapsing into a dim, glowing ember known as a white dwarf. It is a quiet, fading death. But when a massive star dies, it does not go quietly. It detonates in a supernova. For a brief, blinding moment, a single dying star can outshine an entire galaxy. The sheer violence of the shock wave vaporizes almost anything in its path. Planets are shattered into dust. Atmospheres are violently stripped away. Oceans are boiled into nothingness in a fraction of a second. Common sense tells us that a solar system cannot survive a supernova. When the star dies, the planets die with it. But the universe, as we have seen time and time again, refuses to follow the rules. The background soundscape shifts abruptly. The deep rumble of cosmic winds fades, replaced by an eerie, high-pitched, rhythmic pulsing sound, like a distant heartbeat. Imagine a world orbiting a corpse. Deep in the constellation of Virgo, there is a dead star. It is a neutron star, the crushed, ultra-dense core left behind after a supernova explosion. It is only a few miles across, but it packs the mass of an entire sun. And it is spinning. It spins at a dizzying rate, rotating over 160 times a second, sweeping twin beams of intense, deadly radiation across the cosmos like a lighthouse in the dark. We call this a pulsar, and circling this violent, pulsing phantom are planets. In fact, the very first exoplanets ever discovered by humanity were not found around a warm yellow sun. They were found here, in a cosmic graveyard, orbiting a pulsar named PSRB 1257+12. Astronomers named these planets Poltergeist, Phobota, and Drauga, names drawn from mythological spirits and the undead. And the names are fitting. If you were to stand on the surface of Poltergeist, the sky would be completely alien. There is no bright, warming sun, just a tiny, blindingly intense pinpoint of bluish-white light, flashing with terrifying speed. The sky would be perpetually dark, but the planet's magnetic field would be constantly hammered by the pulsar's extreme radiation, igniting the entire atmosphere in a global, endless aurora. Imagine looking up and seeing sheets of ghostly green, purple, and blue fire rippling across the heavens, casting shifting shadows over a barren, irradiated wasteland. It is a hauntingly beautiful, utterly sterile world. But how do planets exist here? How is it physically possible? They may be the ultimate survivors, worlds that somehow withstood the apocalyptic blast of the supernova, left heavily scarred and stripped down to their metallic cores, forever tethered to the spinning corpse of their star. Or, perhaps even more incredibly, they are second-generation planets, worlds built from the ashes of the dead. After the massive star exploded, the shattered debris, the vaporized rock, and the dust of destroyed planets did not just drift away. Eventually, it settled into a new, swirling disk around the pulsar. Over millions of years, gravity patiently pulled the pieces back together, forging entirely new planets out of the wreckage of the old. They are recycled worlds, monuments of stone and iron built from the rubble of an apocalypse. These planetary graveyards remind us of something profound. Destruction in the universe is rarely the final chapter. It is merely a transition. Even in the aftermath of the most violent events in the cosmos, gravity continues its slow, patient work. When old worlds are erased, new worlds rise from the dust to take their place. The rhythmic pulsing slowly fades into a gentle, melodic hum. The tone of the narrator softens, shifting from dark mystery to a fragile, glowing hope. We have drifted through oceans of crushed ice, flown through skies of vaporized ruby, and walked among the irradiated ghosts of dead solar systems. We have seen that the universe is infinitely creative and often incredibly hostile. But amid all this extreme fire, crushing pressure, and freezing darkness, a quiet question echoes through the void. Is there a safe harbor out there? Somewhere in this vast, swirling galaxy, among the billions of strange and violent worlds, could there be a planet like ours? A quiet, temperate world, bathed in the gentle light of a stable star, where the air is sweet, the water is warm, and something is looking back up at the sky. Our journey is about to bring us to the very edge of the greatest discovery in human history. Out of all the chaotic, searing, and frozen worlds we have witnessed tonight, the human mind still yearns for something familiar. After drifting through oceans of crushed ice and graveyards of dead stars, we are looking for an echo, a reflection of ourselves in the dark. We are looking for life. To find it, we must seek out the quietest, most stable regions of a star system, a fragile ribbon of space that astronomers call the Goldilocks zone. It is the habitable zone, a precise orbital path where the temperature is not too hot for water to boil away into steam, and not too cold for it to freeze into rock-hard ice. It is the narrow cosmic boundary where liquid water can pool, flow, and patiently shape a world. But a planet in this zone does not have to be a perfect twin of Earth. In fact, some of the best candidates for life are entirely different beasts. Imagine a super-Earth, a massive rocky planet, perhaps twice the size of our own, orbiting comfortably within its star's habitable zone. Because of its immense size, the gravity here is much stronger. The atmosphere is thicker, acting like a heavy protective blanket that shields the surface from cosmic radiation and smooths out extreme shifts in climate. The oceans on a super-Earth could be unimaginably deep, and its tectonic plates might move with a slow, powerful rhythm, continuously recycling vital nutrients into the soil and sea. Some astrobiologists believe these massive, stable worlds might actually be super-habitable. They could be even better suited for life than Earth itself, offering a wider, warmer, and more resilient cradle for biology to take root over billions of years. But the habitable zone also holds worlds of striking extremes. Remember the tidally locked planets we spoke of earlier? The worlds trapped with one face staring into an eternal fire, and the other lost in a permanent freezing night. At first glance, they seem entirely dead. But right on the edge, along that twilight ring known as the Terminator line, the conditions might be perfectly balanced. Imagine standing in that twilight zone. The sun never rises, and it never sets. It simply hovers on the horizon, casting shadows that stretch for thousands of miles across a landscape bathed in a permanent golden dusk. Fierce winds would constantly howl overhead, carrying blistering heat from the day side to the freezing night side, creating a global circulation system. But down on the surface, sheltered in deep canyons or beneath the ice, life could thrive. Without the cycle of day and night, any flora that grows here would not need to track the sun. Forests of alien vegetation might spread across the twilight band, colored not green but deep purple or black, evolved to absorb the specific wavelengths of a red dwarf star. It would be a quiet, shadow-drenched ecosystem, locked in an eternal evening. But how do we know? How can we ever truly know if something is breathing out there in the dark when these worlds are trillions of miles away? We cannot travel there. Our fastest probes would take tens of thousands of years just to reach the nearest star. So, instead of sending ships, we read the light. When a distant exoplanet passes directly in front of its host star, something miraculous happens. For a fleeting moment, a tiny fraction of the star's light filters through the outer edges of the planet's atmosphere before continuing its long journey across the galaxy to our telescopes. As that light passes through the alien air, the gases in the atmosphere absorb specific colors, leaving dark gaps in the spectrum. It is a cosmic fingerprint. Today, instruments like the James Webb Space Telescope are capturing those fragile beams of light. We are no longer just looking at the size or mass of these worlds, we are tasting their skies. We are looking for biosignatures. A dead world is chemically at peace. Its gases have settled into a static equilibrium. But a living world is chaotic. Life is a chemical engine. It constantly exhales gases that shouldn't coexist in large amounts, like oxygen and methane. If we point our telescopes at a distant super-Earth and detect a massive, unexplained abundance of these gases, it would mean the planet is chemically out of balance. It would mean something is actively replenishing those gases. Something biological. We have not found that definitive signal yet. The silence of the cosmos remains profound, but we are listening more closely than ever before. We are reading the starlight, searching for the faint, unmistakable breath of a living biosphere. And as we look closer at these hidden worlds, a comforting realization begins to dawn. A realization that changes everything about how we see the night sky. For centuries, humanity looked up at the night sky and thought of planets as rare, fragile companions to a few lucky stars. We believed our solar system was a precious anomaly in an otherwise empty, sterile void. But today, the silence of the cosmos has given way to a staggering revelation. Planets are not the exception. They are the rule. In the Milky Way galaxy alone, there are hundreds of billions of stars, and the evidence now suggests that nearly every single one of them hosts at least one planet. That means there are more planets in our galaxy than there are stars in the sky. Trillions of worlds. Some are colossal giants of gas. Some are frozen realms of ammonia and methane. And many are entirely unlike anything we have ever imagined. The galaxy is not just a field of burning stars. It is a sprawling, infinite garden of worlds, each one following its own quiet path, each one a silent possibility in the dark. And somewhere among those billions, somewhere out there in the quiet vastness, another world like Earth might be slowly turning, waiting for its story to be told. But for now, our journey must draw to a close. We have wandered far tonight. We have flown through skies of shattered glass and vaporized ruby. We have descended into oceans of crushed solid ice. We have stood in the shadows of dead, pulsing suns and drifted alongside the lonely wanderers of the deep void. We have seen that the universe is wild, terrifying and breathtakingly beautiful. And yet, despite all its chaotic forces, there is a profound peace in knowing how vast it truly is. If your eyes are growing heavy now, let them close. If your breath has settled into a slow, steady rhythm, let yourself drift. You do not need to hold on to the waking world anymore. You are already a part of this vast, quiet cosmos. You are made of the very same stardust that forged the planets we visited tonight. You are already floating. You are already home. Before you completely surrender to sleep, If you found peace in our journey tonight, I gently invite you to subscribe, so you can always find your way back here for our next voyage into the dark. And leave a soft whisper in the comments below. Tell me, which of these alien worlds will you visit in your dreams tonight? The planets will keep turning, the stars will keep shining, the universe will wait for you. Rest now. Good night.